Hello, everyone. This is Nicolas Vasiloglu, and today we're going to discuss the trends in AI based on what we saw at the NeurIPS 2023 2 months ago. A few words about this review. It was mainly based on tutorials and workshops, keynotes and best papers, invited talks. This time I didn't go through the total of 7,500 papers. That would probably take a full year of work. And I think by the end of the year, things would have moved so dramatically. And I don't think I would remember what I read a year ago. So I tried to dig into the references from the tutorial and the workshops that, of course, come from other conferences as well. And I did compile a comprehensive list of links for further reading. I actually did read as many as I could from those. Now, while the papers are free, the talks will become free probably this week. You can always buy registration, but I think it will become available soon. Just like as a general remark, by attending one of the three major conferences in AI, ICLR, ICML, and NeurIPS, that's the order that they happen every year. You can get a pretty good idea of what is happening in AI, as the tutorials and the workshops usually cross-reference its conference. Now, in a nutshell, LLMs are everywhere, but they're not for everyone yet. As you can understand, ChatGPT is kind of like the queen of language models. Requires tens of millions of dollars to train and deploy. Definitely not, professors and students cannot really do research on the fundamentals of that. So there is a very strong effort in terms of democratizing language models. We need to be able to do and solve interesting problems without having to go to trillions of parameters of models. So obviously, there's a lot of discussion around Llama, which is a free model, but it's not an open source. Okay, so you can download, let's say, the binary, the weights, and use it, but there's no information about how it was trained, the code, the data set, the checkpoints. Which, on the other hand, the LLM 360 is this effort, goes down towards that direction. So everything is available, the checkpoints, the training data, it's fully reproducible. And there's other organizations like Colossal AI that they're trying to give you all the data that you need, actually all the infrastructure, I want to say, with code and functionality in order to train a huge model. It's probably one of the best places to go and clone if you want to train your tens of billions of parameters model. There was another language that we saw that attracted our attention. It's called Mojo. It's a Python-like language that aspires to help people to code everything they need with regard to AI. And it has been developed by people who have a lot of experience developing programming languages. And basically, it's a Python-like language. So you write everything in a Python-like interface, but then they go through several layers of compilation and analysis so that they can provide the best performance. And another thing, it was part of the outstanding papers, the composable LLMs. So how can you modularize LLMs by combining smaller ones? One workshop and one tutorial around LLMs for math reasoning. This is the return of theory improvers. It's one of the first kind of like pieces of software in computer science. And they have applications because beyond mathematical theory improving, they can be applied in legal contract verification, software verification. And they look like it looks like they are a very good companion for language models. Now, whenever you hear about theory improvers, They're kind of, I want to say equivalent, but they're very close to what you see in a knowledge graph management system. Okay. I was very excited about that topic. One of the questions that was we had in the single panel, was only one panel during the main conference, is, are we running out of data for language models? And there are simulations coming to the rescue as researchers find a lot of useful data from simulators. Of course, as you know, I have particular interest in relational tables, and there was this workshop, the tabular representation or table representation workshop, where the idea is, can we train language model directly from relational tables, and can we run predictive operations with language models? Like, can we run what we used to do with XGBoost on a data frame or a relational table with a transformer? Now, for those of you who are old enough, like my age, you might remember that one of the networks that looked very magical in the first era of neural networks was the Hopfield network, where you would give an image which was corrupted, and then it would run several iterations and complete it. The Hopfield networks are back. There was a workshop and I think a couple of papers in the main conference. Not because we are looking for new architectures necessarily, but there is some evidence that we can better understand how attention works and how neural networks work. This is kind of like the holy grail in machine learning for many years. People, use deep learning, it works, but they don't know why. And there was a recent paper that showed that the variation of Hopfield network was equivalent to attention. And it looks like that there's more theory around Hopfield networks that can help us explain why transformer is all you need, attention is all you need. Now, when you go to a conference, you talk about the things that you see, but sometimes the things that you don't see are also important. So I didn't really see any tutorial or workshop about graph neural networks. Probably, I think I counted 42 papers out of the 4,000 in the main conference. And I started seeing transformers trying to do what GNNs are doing. So there's a big question. Is it that people don't really prefer NeurIPS to publish about GNNs, or transformers are slowly taking over those workloads as well? Of course, there's pros and cons to using transformers and GNN. I'm not trying to say that transformer is better than GNN, but sometimes the things that people adopt and prefer, they're not necessarily the best. Okay, they're most convenient. And this is an academic conference. We have to have a little bit of futuristic ideas. I don't know, drug discovery and development. It's not mainstream, although we've been seeing more and more papers and workshops and traffic around that. I'm just noticing over here that I saw a sponsor which I wouldn't have expected to be there. So it's like ByteDance. This is the TikTok parent company. That's interesting that they have some interest in drug discovery. And of course, we all know that we are GPU bounded. They're expensive, they're scarce, they consume a lot of energy, and people are now looking at other compute paradigms. So, that's the place to learn more about that. Again, this is not the only, as you can understand, in NeurIPS attracts a lot of attention. This is not the only recap. There's plenty. This is one that I found. It takes a different angle on looking at the conference, but I think it's worth looking at. So, part one, understanding language models. One of the invited talks was by Christopher Rhee, Stanford professor and founder of many startups in Silicon Valley. As you understand, there's a rally right now to lower the cost of a token generation in language models, and people are trying in different ways, trying to make it cheaper, algorithmically more efficient, better hardware, better software. So Christopher talked about three problems or three topics. The first one is what foundational models. By the way, there is this debate whether we should use language models or foundational models. I personally prefer language models. We can take it in a different meeting. And he refers to the death by 1,000 cuts. If you ever try to clean up data, you realize that you look column by column and you create rule by rule in order to clean them up, regular expressions. It looks easy in the beginning and an interesting task, but every time you're adding another extra rule, another extra pattern, you're putting a small cut in the system, and after 1,000 interventions, you realize it's something very fragile, and the whole system dies. And that's like the death by 1,000 cuts. If you have 1,000 cuts, like each of them bleeds a little bit, but all of them can take the human body down. Then he comes from the database community. He borrows some of the ideas from database systems. So he brings up this example of flash attention and how the way that people do joins can somehow make the attention more efficient. And the last one has to do with applying signal processing ideas in terms of getting more stability and creating some new models like S4. And it always attracts attention and sometimes controversy. The Test of Time Award. Believe it or not, it has been 10 years since Word2Vec introduced itself to the world. We can all remember the excitement when we saw these beautiful graphs of putting words into coordinate spaces and doing some vector operations, and that they have the semantic meaning. So this is the precursor of language models. This is where everything started. This idea that it's much better to represent words as vectors. It was introduced the idea of self-supervision. There were no labels. I'm just mentioning that the two main authors, Thomas and Mikolov and Ilya Sutskever, were not present in the ceremony. Probably, yeah, I don't know the reasons, but again, let's mention that. But Jeff Dean and the other two were there. Now, what have we learned so far by language models? Sorry, but from word to vector until language model. So we started from this paper where there was this idea of context independence. So you got the word bank, whether it's the Bank of the River or the Bank of France, it has the same representation. Then people say, well, let's make it context dependent. And that was the birth of Elmo. Of course, in order to make it context dependent, you need a way of representing the previous words and the words after. So they used an RNN. And then shortly after that, people thought that, well, maybe we shouldn't use RNN, we should use attention. Probably this paper is heading towards the Test of Time Award in about 3 years. And the transformer was born. And of course, how to train a transformer on a self-supervised way, that was birthed. So everybody's using now context-dependent embeddings. That's what language models do. And one of the things that Jeff didn't mention is that they're coming strong again with asynchronous training. For those of you who are old enough in space, you might remember the Hogwild algorithm and the asynchronous STD and the parameter server in the days of training, let's say, logistic regression on billion and trillion of data points. TensorFlow started like that in the beginning. Then for some reasons, it turns out it was better to do things in synchrony, but asynchrony is coming back. Now, if we want to kind of visualize this ontology of word embeddings, again, we go for context independent, Word2Vec, Glove, FastText. Context dependent was RNN based, transformer based. Again, we saw Elmo, BERT, and all its variants. And of course, something is missing here, which is the notorious GPT. That's because there's another way to break transformer based in decoder only, that's GPT, encoder only, that's BERT, and encoder decoder, which is the T5 architecture. And again, the revolution, like context introduced a lot of revolution. So I just want to mention that, Word2Vec was the beginning, but the fact that we could talk about the riverbank and the embedding is here, but the embedding of bank when you withdraw cash is down here. Okay, of course, I think if you're Italian, you probably know that bank comes, I think banca comes from the origin is the bank of the river, because that's where they used to go and trade money and bonds. But in the modern world, we use them separately, differently. Now, surprisingly, when everybody thought that, wow, we can represent the word as a vector, people realize we can represent a whole LLM as a vector. So you can take all the parameters of a language model, there's millions of parameters, and you can pull them together. You can just average each layer, you can concatenate them. It doesn't really matter. You make a big vector, and that's a representation of your language model. And now what happens is you can start doing algebra with these vectors. So you can go and train like a model which is very toxic on toxic data, and then you can take that vector and you can subtract it, and you can remove the toxicity from the new language model. Or you can take a language model that has been fine-tuned or trained to translate from English to French, another one from French to Chinese. You can add them together, and now I can translate from English to Chinese. It's still a work in progress, and we haven't really tested it extensively, but it's a very interesting direction. We're going to talk more about that later. Then, we have the unreasonable behavior language model, where it's this idea, what is happening as we scale from 1,000 to million to billion to trillion parameters. And that was one of the outstanding papers. There was this idea that language models exert these emergent properties, where it means that, you keep adding parameters, we can't really generate words. It does grammatical errors, and then all of a sudden you exceed the threshold and it starts, doing much better. And so what the authors are arguing over here, that if you have different objectives or different measures, there's not really an emergence property, but the progress is continuous with parameters and data. Not everybody agrees with that, but anyway, they did a very detailed analysis, and I think that's what earned them the award. But yeah, so I think it depends on how you look. I think that's what they were trying to say, is depend on how you look at your metrics. They don't really think that there's an emergence, that like there's a continuous evolution. And everybody says that data is the new oil, but are we running out of oil? There's a sustainability analysis of data over here. So there was one of the outstanding runner-up papers was scaling data-constrained language models. It was kind of based on another paper, like, are we running out of data? And it turns out, let me just briefly summarize this for you, that the high quality of data in papers, they're correspondingly 1 terabyte and 16 terabyte, and they will be exhausted by 2024. That was a paper from 2022. Then there's about 14 terabytes of code data, which are unclear of its usefulness. But that paper, basically what it did say is that, look, if you're on a budget, you have, I don't know, 1 billion tokens or 100 million tokens, you want to train a model, there is some value at replaying them, several epochs, but not that much. If you really want to make it more useful, add more, code data. So code data actually is useful, and you can always use them in order to make your language model perform better. Maybe it's our way of infusing logic into the model. I don't know. That's the hunch that I'm having. And here you can see, more plots. Again, there's a lot of content. I will try to we gloss over a lot of this content. So, but feel free when you're on your own, when you have time, you can just go and read more. And here's the paper that I talked about. So we're running out of data. What can we do? So there was a whole workshop called Language Models Meet World Models. So there is a bunch of tasks like embodied reasoning, social reasoning, that we actually don't have enough data, or language reasoning, that we don't have enough data, and how can we train the models? So this is the rise of simulators. Okay, so these are different tasks, outcomes in physics, multi-agent planning, and communication. So people said, well, for the simple task, maybe you can find data, but there's a lot of tasks that you can't find data. So these are the papers that do a lot of simulation. This is here an example of common sense. We call it embodied reasoning, where you give instructions. It says how to move the blocks to the end state, and language models don't behave that well. And there is also a big problem when it comes to social tasks. We know about the alignment problem and toxicity, and being compassionate. And here are papers that you can go through and read more detail about existing simulators. Now, you probably do remember that that whole wave of probabilistic programming. So probabilistic programs are very close to what we call simulations. Okay, so the probabilistic programming community is moving towards fusing language model and probabilistic programs in order to improve the reasoning. So you could either generate data to train the language model, or you can train a language model to generate probabilistic programs in order to achieve a task. And there's a detailed info. You probably recognize this is, one of the people over here, Joshua Tannenbaum, Vikas Masinga, Noah Goodman. They're very well-known people in the probabilistic programming community. I think it's a very interesting paper about how you can combine these two models. Don't forget that language models are also probabilistic models. And here's another paper that basically says that here's how you can use the language models in order to create a reward model for reinforcement learning. There were plenty of papers over here. Some examples about using language models and social information, like social skill information, in order to do better social reasoning, jumping from 12 to 69%. And of course, don't forget that games are excellent simulators as well. So Voyager is an interesting system, again, by Anand Kumar, also published a lot in this venue, about how you can combine prompting and games for creating better language models. Again, more papers on the alignment problem. There's the social simulator. And something else which I found really interesting is this Dream LLM, where if you really want to create a sequence of, let's say you want to learn from images how to solve a task. So you ask for the language model to dream. Now, going back to 10 years ago, probably 9 years, that was where, yes, 10 years ago, that's probably going to be the next test of time, was the GAN, the generative adversarial network. Is that the precursor of Gen AI, actually the beginning of Gen AI, where you used to say that the machine is dreaming. So here you're doing the same thing, you're asking them, asking with prompts. Imagine you're a robot in the house. How would you walk through the house? I would look for my mobile phone on the table. So it starts generating images and guiding how to solve a task. And there's plenty of examples in the paper. So the takeaway is, language model, the word model, you move towards this agent abstraction, and you can so the word model basically here means like the simulator. Okay, you do better as language, embodied, and social reasoning. More in the tutorial. Okay, so we're gonna take a break here, and in the next session, we're gonna talk about distributed language models, composing big models from smaller ones.